Thank you, Martin. And good wherever time of day it is for you. It's 7 o'clock in the morning for me. I should be substantially waking up by now, but maybe not as wake up as later in the day. So if I'm kind of sounding stupid, then you may know that's why. And today we'll talk to you about optimizing and troubleshooting MySQL with PMM. This is how the presentation will go. I will talk to you in general about the approach to the performance optimization troubleshooting, what we are taking. Then I will make an intro in what PMM is, and then hopefully I spend most time showing you the demo. How is it working in practice, right? So let's look about performance optimization and troubleshooting, right? I'm using those terms, and I like defining terms, right? So what is the difference between those two? Now, if you think about the performance optimization, obviously it is focused on performance specifically. And related things, like scalability, managing the cost, and so on and so forth, right? You typically do performance optimization in development or production, better in both places, right? Because there are, if you do not work on performance in your development and you just launch unoptimized code in production, you will crash and burn. But also there are many problems which you would not catch in development, right? So you do need to make sure you can do performance optimization in production, right? For example, as Valerie, who spoke before me, it is good to make sure you have all the tools installed so you are able to do that. With performance optimization, though, is as much as possible, you want to do that proactively before your system suffers a downtime or unacceptable performance levels for your users, right? I think that is important to remember. Now, what is troubleshooting? Well, troubleshooting is what you do when things break, right? When you are having some problems in your system, and that may range from performance problems to system is kind of down, and you don't know why, right? It's may or may not be performance related, to debugging certain things, like maybe you are not getting results you expect, stuff like that. Again, it can happen in development and production, but troubleshooting is reactive by nature because that is focused on resolving the problem you have. Now, when you look at those things, right, especially for performance optimization, right, you can take a different view for that from a standpoint of different stakeholders, right? If you think about the developer, right, typically the idea is that they just want this database to work, right? If you're not DBA or kind of developer slash DBA who is like really passionate about the databases, you just want to make sure you can use database to develop your app and it gives you no problem. Now, if you think about the manager standpoint, right, especially higher up in the management chain, and especially in times like this, right, when a lot of businesses are facing the reduction in revenue, the manager also wants to ensure the database doesn't cost so much to run, right? So we want performance, but we want to be, but when manager adds to that what he wants, an efficient performance, of course, right? Not the performance at any cost, right? If extensive tuning by the credit card. And then if you look at their outcome for DBA, well, there is yet another problem which comes here, right? DBA obviously needs to keep the development team and his manager happy, right? And he can be sort of like as a rock, what is between the rock and a hard place, what we're saying goes, right? And he needs to make sure what he doesn't spend too much time and effort doing that. Not because the DBA is lazy. Most DBAs are not, but there are some who are. But just because the DBAs are increasingly stretched things, many DBAs support large amount of development teams. I know companies now who may have the ratio of hundreds of database servers, right, and maybe more than 100 of applications per single DBA head, right? So they are really stretched to things, and they need to make sure they can be efficient. Okay, now let's look at the high level what performance is from an application development standpoint, right? Think about the database in this case as a black box. If I am developer, right, I only have a superficial knowledge about the database. What do I expect of it? I expect that I can connect to database and run the queries. I expect I can run those queries with a great performance, right? They provide the correct results. Also, they're not impacting other applications too much, right? And also they do not take too many resources, right? Last two, they would come mostly from DBA and manager in this standpoint, right? But in many cases, they are kind of explained and understood to their by the development team. Now, I think what is interesting in this case is what if you think about the database performance, as very many things in a modern world, it can be defined as a shared responsibility, right? Because the application has its part of responsibility. What it is responsible for volume and the kind of queries it generates, right? And in many cases, their work on the database can be focused on the application queries when we are looking at having the application to send less amount of queries and easier queries to write queries which are simpler to run for a database to have the better performance. On the other hand, you can also think about the database performance from a resource focus, right? Because if you think about your database, which has its resources oversaturated, then even simple queries, easy to run, right, well optimized, will be very slow to run, and the application and end user would suffer. Now, if you think about the resources, right, what resources I mean? First and foremost, I mean your primary hardware resources, right? Like you can be having a situation of a CPU. You may have not enough memory for system to work effectively. You may have poorly performing or saturated disk or network, right? These are their most important hardware resources, and a lot of performance problems will be seen as using right or bottlenecking on one of those resources. Not all of them. It is possible for some performance problems to happen just due to internal MySQL issues, right? But as the time goes and MySQL becomes better, there are less and less of those issues. Okay. Now let's think about the resource utilization, right? Where it can come from. Of course, hopefully primary resource utilization comes from your application queries, right? Which is what you can focus on, but not all of them. In many cases, a lot of resource usage may come from other queries, right? Especially in complex environments, typically single database may support more than one application, and it's maybe other folks running the queries which impact your performance, right? Also, you may be looking at database background activities, which are doing something like a database may be taking a lot of resources doing the replication, right? Or it may need to do some other activities internally, right, like the checkpoint and so on, which can be taken resources while they are not correlated to specific queries. You also may have other processes running on the same system on the same node, right? And it may run from something database related, like, hey, I kicked off Percona Extra Backup and running a backup right now, which takes a lot of disk resources, right, and some additional memory. Or it may be something which is not related, right? Maybe you have some some little application which is a bad job which runs locally, and it can consumes a lot of memory, right? Or some runaway system process, right? A lot of stuff can happen. Finally, in the cloud and in virtualized environment, we also have noisy neighbors, right? Some other applications which are running within constraints of the same physical infrastructure, sharing the same physical infrastructure of your application, which can impact its performance. And again, over time, virtualization gets better in terms of resource isolation, but it is still not perfect. Now, if you think about that, I have explained kind of two paths you can really take as you look at your performance things, right? You can look from the query side when you look at, hey, what exactly is going on with the queries, and you can think about from approach right from resource side. And with Percona monitoring management, we strive to enable both of them, because in different use cases, one or another may be more optimal. So what is Percona monitoring and management? And if you've been following Percona for substantial time, you probably know all about this tool. If you are new to Percona ecosystem, let me explain what it is in a few words. Right, Percona monitoring management is our purpose-built monitoring observability platform focused on databases. Right, it is 100% free and open source, and it is roll your own solution, right, which you install your own system on-prem or in the cloud. It's can be installed very easy. For example, it's available from Amazon Marketplace. It can be deployed in a few clicks, and it supports open source database which Percona supports directly, such as MySQL, MariaDB, MongoDB, and Postgres, and it actually can be made to monitor other systems too, with concept of with some external integrations, right? And we support both your on-prem deployments, right, or do-it-yourself deployments, as well as cloud-based deployments such as Amazon Aurora and Amazon RDS, right? Obviously, the level of information you will be getting is different, but we support both. And our goal, really, in this case, is to bring together your dev and ops to build a better applications faster and run open source databases better and more efficiently. Now, I'm going to talk about the PMM2 in this presentation, which was around now for about 6 months, though many users are still running PMM version 1. Their PMM version 2 is our major rewrite, which was focused on supporting much larger environment, providing much deeper insight all around, and really embracing this approach. What many organizations start to look at the groups of servers rather than individual servers, right? You may have heard this concept about treating your server as a herd, not as pets. And while we still have a lot of database servers, which are being really kind of pets, right, and have every single server is critically important, we are moving in more and more to the organization, to the environments, right, where it's more as a a database service has also been looked as a herb. Okay. And just fresh off the press, if you haven't heard so, is that we released Percona Monitoring Management 2.6, which provides an additional feature in terms of helping you to secure your database from some basic security mistakes. And this is something I would say a lot of DBAs would find very basics, and I probably can imagine how if you rolling your eyes right now, but a lot of data leaks as we see in the industry happen from a very, very basic mistakes, like not setting the passwords right or not updating your database software. And that is what we are focusing on preventing first and foremost with this tool. Okay. There are also a couple of links I'll leave in this presentation if you guys want to check more of a PMM. And with that, let me see if we can get a graceful transition to our demo. Let's see if we can, or if we can't. Okay. Hopefully you folks see my screen now, do you?
Yes, we do.
Okay. Okay, thank you, Martin. So this is how the PMM looks, right? If you look at the overview, right, which essentially provides you the overview of your servers, which are running. This is my demo environment, right? And you can see the different nodes here with the most important resource usage information listed out there. In this case, we can see some of the nodes actually are not database nodes, like client 1, 2, 3, 4, right? So you can actually manage and monitor the generic Linux instance of PMM as well. It is just not particularly designed for that. Right. Then we have a number of MySQL nodes, and we can see, for example, MySQL 1, seems to be doing relatively healthy, right? It has a 60% CPU usage, while I have some other nodes which are overloaded, right? If you have 100% CPU usage, well, that means things are pretty saturated right now. And we can also see memory usage, disk I/O, network I/O, right? Some database information, and so on, and so on and so forth. Now, let me first show you the query information, right? In terms of the query information, we call this query analytic tools, right? By default, you would see all the queries which are running in your environment. And by default, the queries are sorted by something what we call the database load, right? The other term which is used with that in the ecosystem is average active sessions. So if you look in this case, and we have this update query, which has a load of about 30, that means is what this query has across all my system. 30 queries are running in average at the same time, right? So, and we can see what this query in general provides about the 40% load, even though it does not correspond to the very large amount of queries, right? You can see it only has approximately 20 queries per second compared to others, which has a lot more on that. Now, you can also sort by the different options, right? I can see, for example, my most frequent queries, and we will see, the different query, which is selected by the primary key. Or if you want to look at the queries which are slowest in average, right, we can sort by the query time, and we can see what this update query is actually also the slowest. It takes 1.2 seconds in average, but then we also have this information schema query, which is the second right? 1.1 second in average. Even though this query, while it's rather slow, it generates only 0.1% of a load, right? So that is very much non-sustainable. Now, one thing about the performance optimization is also looking at averages often doesn't really make a lot of sense. And with that, we provide a lot of opportunities to break things down. So for example, on the side here, I see different facets, which are by schema. So for example, I can see what 30% of my load, right, comes from TPC1 schema, right, and 80% of the load comes from the MySQL2 node, right? So you can actually see where that load comes from and what it is in focus in our optimization. Now, if you think what exactly those numbers mean in the faceting here, is these all corresponds to that primary column which I show you here. So for example, I can choose to have something else and say, well, you know what, I want to show their bytes right now. That's not even MySQL thing. You know, I should not pick something which I do not. Oh, rows examined. That is something which is interesting, right? So we can look at what queries actually analyze a lot of rows here, and we can see by the rows examined we have now different numbers. Now we can see for rows examined, it's TCP one schema has a whole 94%, right? If we focus filter by that schema, all right, we would see now what we have MySQL 4 is where majority of that that load comes from, and we can see specifically what 99% of those rows read, they come from this particular query. Right now, then if I click on that query, I can really look into some more details in terms of, hey, what is going on out there. And some of the valuable information here you can see here. You can see what that query in average sends per each query. It sends the one row in average, but it scans 100,000 rows, or about 100,000 rows per row sent. This is actually pretty bad, right? Pretty inefficient. And I can then look at explain for this query, and I would see what this query in particular does not use any key, even though it's basically selected by a single column. Well, in this case, of course, I deliberately dropped that key on this table, on this host, but in reality, you'll often find something similar to that in your application. Okay. Now, this one, in this case, what we have been focused on looking at the top queries, but that's not only a way we can look at, right? We can also, instead of queries, take a look at, for example, different client hosts. In this case, the client hosts, they are rather similar in terms of work they have generating, right? You can see load is almost exactly the same, all right, but it is possible for that to be different, right? Oh, actually, yeah, you can see it's a little bit different between them now, but in reality, we often see only one of the web servers or something generates unusual load, right, which can correspond to security incident or some code which wasn't updated, or maybe some cache misconfiguration, or so on. That can be very helpful. You can also see a breakdown by users. If you are following a good practices, you would use a different usernames for your different applications, and that can help us then to understand which applications are causing more load, right? And you can see in this case, this up1 application is responsible for about 60% of the load. And we also can look at the different database instance, right, where we can see majority of that load comes from a MySQL2 instance right now, right? So you can really get a lot of detailed information. Yeah, schema, that is another important number. Why is that important? Is because a lot of applications right now with MySQL, they use multi-tenant approaches. They use schema per database setup. And what that means is every tenant, every user would has its own database, and often you would have some naughty tenants, let's call them, right, which generate disproportionate amount of work for your database and become the problem, while the average tenant just works quite fine. Okay, so this is the PMM query analytics. As you can see, you can go really in depth to understand what queries are causing the loads, right, where they come from, and really what to do about them by analyzing, explain, and so on and so forth. Okay, now let me, before we jump to some other cool stuff, and before I get carried away and use all the allocated time, show you some other goodness, to show the security tool, which I just installed on this system. And you can see in my test setup, I have some warnings in place, right? And if you click on the link on the home dashboard, you will get the details. Like in this case, I see just one check failing. I have, because it's a test environment, I had to set up some users with empty password, which the tool tells me, well, Peter, that is not a very good practice. So something to be aware of, and something that we are continuing working right now to improve and extend. Okay, let's look at the node summary, right? And what do we look at from a standpoint of node, right, or of a system? In this case, a lot of our focus is around the resource usage, right? For example, for CPU, we'll show you CPU utilization, but also I think what is very important is this graph, which talks us about the CPU saturation and max core utilization. Why max core utilization is important? Because especially in MySQL, single query can execute only one on one CPU core. That means even if you have some extra CPU capacity in some of your applications, you may not have you may be still blocked by the given core performance. And in this case, we can see to what extent the core utilization is if there is an overly saturated core. What is the CPU load is now a very important metric, right? Because even if the CPU is not 100% loaded, right, or 100% loaded, it's may correspond to a different amount of processes which are actually waiting for CPU to become available. So think about this case, right? If I have a single CPU core and I have one CPU heavy thread which just runs and does a job it needs to do. Well, I would have a CPU usage of 100%, but my performance would be actually as good as it gets, right, at this point, because I only have one CPU, the intensive task, which has a CPU core to run on. Now imagine we have 100 of the same tasks. In this case, and single CPU core, right? In this case, of course, I will have a lot of saturation happening in or I will have 100 CPUs I could possibly consume, right? But only one core available, right? That means I would have what is called one thread on the CPU, and then additionally 99 threads which are runnable, which will show up as a high saturation, right, or high normalized CPU load. So typically, if you have a normalized CPU load of more than I would say a 2, right, then that means your system would likely benefit from having more CPU use available. In terms of memory utilization, you can see the breakdown of how that's memory usage. And for memory, I like looking both of your kind of physical memory as well as virtual memory, because if you have a problem where you run out of virtual memory, right, which is defined as your RAM and a swap file, then you will have the MySQL process killed by out of memory killer, right? And that will cause a little bit, downtime or failover, will require for it some time to recover. So not a good thing. So that is because of that, my preference is to make sure you have some spare virtual memory available. If you have some additional unexpected memory increases, your system can absorb that. But at the same time, you want to make sure there is not a significant amount of swap activity going on. Like, so for example, in my case, you can see I actually have some swap space used on this node, but at the same time, I do not have any swap activity going on. So really, the system is not swapping. It is just some unused junk which was swapped out to a swap file, which is a good thing. I/O activity, disk is obviously another very important thing. For I/O activity, I like to look at the disk throughput, which tells us how much work it is doing, as well as a disk I/O latency, which we look at both reads and writes separately. And because storage is so different, I like looking at that disk I/O latency current compared to your kind of historical average, right? In this case, it's average for an hour, right? You can see in this case, it's kind of a pretty normal. There is not super significant outliers. But in certain cases, when you have, let's say, your disk craps out for any reason, right, you would see what your average latency, your latency spikes way above your average, right? And again, this could be disk problem, or it could be substantial inflow of work, right? So much what disk cannot keep up. Another measure for how my disks are loaded and how much extra work can they do can be seen from this disk I/O load idea, which pretty much tells us how many queries are active at the same time, right, or disk I/O request. In this case, when we have less than one read and write active at the same time, I can see what this disk is not really loaded heavily at all, right? So it does some work, but for this disk, that is peanuts. And the same applies to the network traffic. Now, for network traffic, that is where you need to watch for errors as well. Because unlike, let's say, disk I/O errors, which would call instantly MySQL crash, right? Or let's say some memory errors, right? Or CPU errors, which also cause the same effects in many cases. The network errors, they just slow things down. Right, for you in many cases. So if you have, for example, local network interface which is misconfigured or which is kind of dropping packets, right, and have some, check some errors and so on and so forth. Well, TCP/IP protocol will correct for that, but it will just cost you a lot of performance. And the other thing besides local network error, I like looking at the TCP/IP retransmission, right? Which if you have a heavy retransmission rate, especially if it's kind of more than normal, substantially, that can be often cause of your of a problem. But then we can get there a lot of information about the MySQL in particular as well. In connects, client activity, what's kind of select operations are going on, right, and so on and so forth, right? You can see what command counters have been doing, and a lot of other things. This one is also, I think, in particularly interesting. That tells us, if you look at the show process list, what is the summarized stats of what is has been going on. In this case, you can see majority of my threads are idle, right? Makes sense. In some other cases, you will see, oh, a lot of my threads are stuck in the locked stage, right, or something like that, which can give you some very good insights. Okay, another tool you can use a lot, especially for more advanced diagnostics, is their EnergyBe Dashboard, which does have a lot of information about all kind of EnergyBe activity, right? So from activity standpoint, you can see, for example, number of rows read and number of rows written, which can be very helpful to understand the load the system is handling. And I think what we do here is show information about a lot of general transaction information, right? Like a lot of people would ask me, well, you know what, how do I understand is my read traffic or write traffic going on? In this case, a workload is quite interesting, right? So if you look at the number of rows, we can see what's really much less than 1% of rows are being written. But at the same time, if you look from transaction standpoint, then a lot of transactions, they have at least one write in them. And why is that important? Well, because if I want to offload some traffic to the slaves, right, often I would need to, the most easiest way to do that is to offload the whole transactions, right? And in this case, it's kind of tough to do because all transactions, they do something else, right? We can also look at how complicated transactions are. And in this case, we can see, well, average transaction gives us about 16 rows writes per second. Not very large, right, as well as, but it scans a large amount of rows, right? So you can get a lot of those the information as well. Some other information, right, which is interesting, right? You can we can see about the storage summary, right? For example, how much data fits in a buffer pool, and some other information, right? The data length, how much data and index used, the fragmentation, right? Like, for example, in this case, you have about 15% of the data. Not a lot, right? In some cases, you would delete some data, you will see that like at 80%, when running something like an optimized table may be due to reclaim that space. You can also go quite deep in analyzing EnergyBe disk.io. In this case, I also would know this particular interesting item in terms of pending IOs, right? Which shows you how many IO operations are actually in flight, right? Both from kind of normal the read writes as well as fsyncs for log file. This can be very valuable if your storage experience some stalls, right? Sometimes the storage, especially in the cloud, may have some stalls where you would have like a spike of pending IO really skyrockets to hundreds of IO requests and actually just stays there for several seconds or more, right? And your database kind of just grinds to halt for a period of time. You often can see that very well in this case. Another graph I like to show is this, right? Which shows us in this case the EnergyBe checkpoint age versus the max checkpoint age, which is defines pretty much as how much log space in EnergyBe is used. Like some of you may know what EnergyBe write performance especially can depend a lot on your log file size, and if you have too small log files, then the performance wouldn't be optimal. And the best ways to see that if the log files are there, then is exactly using this system. If your uncheckpointed byte space gets closer to this red line, then it's likely you don't have enough log file space. In this case, it's a small fraction of that, so it is not a problem. Now, another thing I wanted to show you in this case, which is a pretty advanced Grafana feature, is also what's called the Explore mode. What this gives you is essentially open up the same dashboard in a way when you can edit all the queries, right? And you can essentially edit them in any way you like, right? So, for example, in this case, I am looking at 5 minutes averages. Oops, I probably removed too many brackets, right? And I can look at to change that to, I don't know, let's say 60 minutes, right? Which will give us more smoothed graph, right? Or if I remove this thing, right? I can really that wouldn't change much in this case, right? Because I only look at one node. But if I look at the anyway, so let me just remove this thing to show it, right? If I look at showing just data reads, right, without any filtering, I can potentially look at the data reads for average over hour for all of my nodes, and here I can see the details, like what those corresponds to the MySQL 1, 2, 3, 4. Anyway, so that can be very powerful, right? If you want to take one of the graphs that you're interested in, then kind of play it, either to add some additional filter or modify the query to serve your application purpose better. Okay. Now, the other cool thing I want to show you is this. If you look at PMM, it also ships their ClickHouse inside, and that is where all the query data is stored, and you can actually retrieve that data from that ClickHouse directly. In this case, I built this dashboard myself. It's not part of a PMM, but I will share that publicly, and you can see a lot of information, right, which can be queried from that, right, like number of queries, latency, and so on and so forth. Again, I can have a explore mode in this case, and what you'll find quite cool here is you'd have pretty familiar the SQL queries where you can add some additional where clauses, right? If you want, and what's not. Here is maybe some another dashboard which may be interesting for you folks, which I created for this demo. Some of you may have heard about the method called RAID, right? Rates corresponds for rate error durations. And if you want to look at how your database performing or your any kind of system, that's maybe very valuable, right? So that is what I have done in this case for my database, right? I can look at the queries, I can look at the what is the error rate I'm getting for queries, right? And a lot of that is expected, right? Because I do have workload that generates a fair amount of deadlocks. And I can also look at my the query latency, like P99, right? That means 99th percentile as well as the average latency, right? In overall per node, right? And then I can really also, oops, I'm not sure why does it didn't show me for all. Well, anyway, here is also something I want to show on the dashboard is a little cool, which is available in Grafana, which is called ad hoc filtering. What that means is I can actually filter that dashboard by something which by any clause, right? Like I can say in this case, well, I have information about the rows sent, and I now want to look at all the queries which send out at least 10 rows, right? Max in this case. And what you would see in this case now, I have only 3 QPS of such queries, right, and only 1 unique query per about 15 unique queries, right, which do this kind of thing. So which I think is pretty cool. Okay, the last thing I wanted to show you is what you can actually take that even to the next level by looking at some queries directly in a ClickHouse, right? So if you connect, if you're running a Docker and you PMM deployed with Docker, then you can use this command to connect to your local ClickHouse. Then you can connect to PMM database, show, oops, copy paste, like too fast with copy paste. All right, so you can see, for example, the definition of all the data which exists in this table metrics. What is cool in this case, you can see we have comments for most of the data, so you can really understand pretty well what's going on. And let's kind of show some queries, right? So for example, if I want to run oh my gosh, okay, if I want to run the query which let's say shows us how many queries were run for since a given period of time, right? So I can see number of queries. That's maybe not be very very helpful. So let's come up with something else, right? If I want to look at their average query time, right, which average query response time over the last 6 hours. In this case, you can see that as time in seconds, right? So it's about 77 milliseconds. And you can see this is in most cases, that is an SQL, which is pretty similar to MySQL, but there are some functions which are different, right? So for example, instead of using MySQL's date sub, I have to use subtract hours in ClickHouse. but you will be able to find out that pretty quickly, right? Another example would be the most frequent queries, which you can find here, right? In this case, I show another interesting ClickHouse feature, which is called with totals. What that gives us is, in addition to computing the top 10 of the queries, I can also see how many queries there have been in total. So, for example, I can understand the percentages, right? If you guys remember the query analytics I showed you, the first query was like about so, a high number of percentages, right? I forgot what it was, like 40 something percent. Well, you can see that is pretty much how math works out. And you can also do filtering. That is where a lot of powerful stuff comes in. Like in this case, if I want to see the top queries which are hitting the particular box, right? MySQL 1, right here is example you can use. Now, I'm obviously going through that pretty quickly. But there is also a blog post I published recently about advanced MySQL use with a ClickHouse, where you can read on in more details and see examples of all those queries with some additional commentary. I want to end with second. What is it somebody saying? It says we have 3 questions. Okay, yes, my reminder to leave some time for questions. Okay, so last query would be this. So you can also filter by the queries, right? Query text. And in this case, if I want to do something like find all the queries which contain delete, right? Or that can be table name or certain expression. I would point out that the data in ClickHouse is compared case sensitive by default, right? So that is different from MySQL. So if you want to have case insensitive collation, then you would need to use lower UTF-8 function, right, to bring it to a lower case, and I sub UTF-8 encoding for the query data, and then run the like on that. And that will, in this case, I'm looking at all delete queries, and you can see what, while most of the queries this way, I would actually do see. In this way, I'll also have some queries which are not, well, not really delete, just contain delete somewhere. Like in this case, I have a some timer delete in the query, not delete kind of query. Okay, anyway, Martin tells me to shut up and go ask some questions. So let's do exactly that. So what's the questions, Martin?
Okay, so we have 4 questions. The first one.
4 questions already. Okay.
Yeah, you're a popular guy. Bob Sparks, he asks, does it support MariaDB as well?
Yes, we support both MySQL and MariaDB.
Okay. Second question was 2 questions from Jose Garcia. He says, I guess PMM requires performance schema to be active. How much impact does all this monitoring add to the database?
Well, PMM can use either performance schema, or it can use slow query log. There, in Percona Server in particular, we use a sampling feature. So if you have 100,000 of queries a second, you may not want all of them logged, by only fraction of them. Like for example, 1%. I would say the overhead, if you enable performance schema, would come from mainly enable performance schema. Our target goal with PMM is what it would add another, a couple of percent of overhead tops, right? Which is typically is not a lot to pay for information it provides, which helps you to shave off, much more by proper optimizations. PMM is also quite flexible in terms of what you can do in terms of settings. Like you can actually configure the resolution in terms of how actively it scrapes the data, and if you want to reduce the overhead, you may configure the resolutions to be lower, right? If you want high fidelity data, and you can have enough CPU resource wherever, you can go to higher resolution.
Okay, that's super. And there's a second question from Jose. He asks, can the performance schema be activated without downtime?
Well, when you speak about performance schema, there are two items here, right? There is a performance schema in general, which is enabled or disabled. If you have a performance schema disabled completely, then as I remember, you would need to restart your instance to enable that. At the same time, if a question is about the performance schema settings, such as different collectors, then a lot of them can be enabled at the runtime, right? What kind of information performance schema collects?
Okay, super. And then the very last question, if an organization has got a Percona support agreement in place, are they able to send us their observations in order for us to investigate those?
Yes. I mean, if you, our support team works very actively with PMM, and there are both features how you can share information from PMM at Percona, as well as often we work together with a team to use PMM to troubleshoot things from either having access to the PMM or through a screen sharing, right, or some other means.
Okay, great. Thank you, Peter. That's the end of the questions, but I would encourage everybody to continue to contact us through the Slack channels and the YouTube chat as well. Peter, that was a great session. I would now like to hand over to our next host. It's the man who wears many hats in Percona, but he is our resident master of ceremonies, and that's Matt Jonkovic. Over to you, Matt.
Thanks, Martin. And good morning, good afternoon, good day, wherever you guys are. Appreciate you sticking around for the 22 hours that we've been online, and we're about ready to move to the 23rd hour.